This presentation will demonstrate the Teamcenter integration to Altium for both designs and libraries. In the first section, we'll look at the design integration, the embedded Teamcenter menu, and an initial design save. In Altium, I have a sample project open with a schematic and a PCB layout. I also have project parameters defined for things like the description of the project, the power, and the rating. The integration within Altium embeds a Teamcenter menu. Within this menu, we have options to search for and open designs from Teamcenter into Altium, save those designs back to Teamcenter, save them as to a new part number, increase the revision level, check them in, check them out, initiate workflows on both designs and component parts, compares bills of materials, as well as to get design information and look at the Teamcenter inbox for workflow tasks. In this example, we will do a save as to save this new design to Teamcenter for the first time. The Save As dialog shows all the structure that will be created in Teamcenter. At the top level is the PCA, or printed circuit assembly. It is the root level for the entire design in Teamcenter. It already has an ID and a revision assigned to it, as my configuration automatically pulls part numbers for new objects. I can also assign the ID or enter an ID manually. I can change the name of the project just by entering a new name. The PCA has links to all the other data that will be created for this project within Teamcenter. The project will contain a bill of material. During the save process, a parts list will be generated from the project, and this is used to build a bill of material within Teamcenter. The Altium design project is contained in the design object. All the data for the project will be in this container. Create a visualization file for the PCB layout, as well as an object part number for the PWB, or printed wire board, or the bare board. This is so that we can represent the board itself in the bill of material, and we can also change its name. With a base installation, we would now hit finish and the design would be saved to Teamcenter. But a common configuration is called derived data. Derived data has two parts. The first is the ability to generate additional part numbers for a design. In my example, I'm creating a part number for a drawing and a part number for my manufacturing data. One or more additional part numbers can be generated for every design automatically using derived data. The second part of derived data is the ability to take output files and save them to their own objects within Teamcenter. So here you can see I'm saving PDFs of various drawings, board drawing, schematic drawing, as well as the Gerber, ODB++, and manufacturing drawing. These can be picked up from the design if they were previously created by the designer, or can be created during the save process by automatically running an output job file. Once we have the structure the way we want it, we can finish and the save will commence. You can see the output job running in the background, creating the output files that are going to be saved to separate objects in Teamcenter. The save progresses, and when finished, we can close the dialog. We will now review this project in Teamcenter. Within Teamcenter, we use a quick search to find the design we just saved, and we'll open that project. On the right, we can see an overview of the project, and on the left, the bill of material. To better see the bill of material, let's open it by itself. You can see the board representing the PWB part number that we defined during the save, as well as all the other components that make up this design. We also have the reference designator information for every component. And if we have multiple instances of a component, we pack the reference designators. Back to the overview of the design, we can see some of the properties that were mapped between the design and Teamcenter. The description, the power, and rating were attributes in the Altium design that we mapped into Teamcenter properties. Properties can be bidirectionally mapped between Teamcenter and the Altium design. To see the project structure, we'll use the relations capability within Teamcenter. See the project structure, the project part number at the top, and all the other data related up to it. You can see the board design object containing the Altium design files, the visualization file of the PCB layout, our layout drawing output data, our board part number, and our extra part numbers, in this case a drawing and a manufacturing part number. We also see more output data such as the ODB++, Gerber, and the schematic drawing. To open any of these, I can highlight them and have them open. In this section, we will look at the PCB visualization. In the Relations browser, we can look at the PCB visualization object and open it in Visualization. Within Visualization, we can see the layers of the PCB that we can turn on and off, both sides of the PCB board, as well as the bill of material. We want to find where a certain component is. We look for it in the list, click on it, and it will be centered and highlighted. If we find R2, then we have to find D2. We can also find nets and see where those are connected. We can mark up and interrogate the design. We can inquire about distances, radial distances, routed length of nets. As an example, we'll take a couple of distance measurements from chip to board edge and from chip to chip. Other markup items such as text, arrows, circles, highlighting can be added. These markups are then saved against the visualization object within Teamcenter. Now let's open a design from Teamcenter into Altium and then check it back in. Within Altium, we'll use our Teamcenter embedded menu to open a design. The open dialog is the same as a Teamcenter client. As in the Teamcenter client, we can search for a design. We can open the design, and then we have the option of opening it into Altium for changes or just opening it to view it. We will open this design for modifications, and the design is downloaded and opened into Altium. With the design open, let's review the project parameters. We have parameters being set from Teamcenter, such as the project ID is the part number of the project in Teamcenter, the revision is the revision level in Teamcenter, and the project title is the name of the project in Teamcenter. This shows the ability to map properties between Teamcenter and Altium bidirectionally. These properties are being used to fill out the title block in my schematic sheet. With the design open from Teamcenter and checked out, you can now go to the Embedded Teamcenter menu and either save the design to Teamcenter and continue working on it, or check it into Teamcenter. When we check it in, we can see the same dialog as we had during the save process, except the part numbers are set as we open this design from Teamcenter. We can finish, and the design will be checked back in. In this section, we will look at initiating Teamcenter workflows from the Altium integration. From the integration, we can initiate a Teamcenter design workflow. We can enter a name for the workflow, as well as some additional information to pass along to the reviewers. The integration defaults to having the currently open design as the target of the workflow. We can also search for any other design in Teamcenter to add as the target. We finish, and the workflow is initiated. We can check our Teamcenter inbox to see the status of the workflow. You can see the workflow is at the design review task. We can also get the Teamcenter information about a design by using the Teamcenter Design Info selection. The bill of material, overview, any attachments are shown to us within the Altium tool. Now let's look at saving a design with defined schematic variants. Here we have an example design with a schematic and PCB layout. We can also see we have 3 variants defined. Go to the variant dialog. You can see that these 3 variants called V1, V2, and V3 have various components that are not fitted, C1, C5, and C6, as well as R1, R3, and R10. We use the Teamcenter integration Save As to save this new design to Teamcenter. At the top level, we see the PCA printed circuit assembly with its ID and revision assigned. We can change the name. All the rest of the project elements relate up to the PCA. We have a bill of material at the project level. This is the bill of material without any variant conditions applied. Also see the design object containing all the Altium design files, the PCB layout visualization, the printed wire board or bare board, the derived part numbers, in my example a drawing and a manufacturing part number, as well as our derived files, which are our output job files saved to separate Teamcenter objects. You can also see a separate part number for each of the 3 variants. So each variant gets its own part number within Teamcenter. Each variant part number contains a bill of material. This bill of material is what is populated in that variant. So the bill of material under variant 3 contains just the components populated in variant 3. Each variant can also be renamed. And once the structure is set up the way we want, we can finish and process the save into Teamcenter. Now let's review the variant project in Teamcenter. Within Teamcenter, we can do a quick search for this project and open the project. You can see the attributes were mapped from the project into Teamcenter. And we can see the bill of material for the project. This is the bill of material without any variant conditions applied. So if we sort by the reference designator by clicking on the top of the column, we can see C1, 5, and 6, as well as R1, 3, and 10. If we look at the relations browser from the project, we see the project at the top level. We can see the board design data object, the visualization file, the derived part numbers, manufacturing and drawing, as well as the board. We also see the variant part numbers, variant 1, variant 2, and variant 3. These currently contain a derived data set. We can open the variant. Looking at the variant, we can see the bill of material. This bill of material is what is populated in variant 1. So if we sort by the reference designator, we can see that C1 is missing, as well as R1 is missing, because it was not populated for this variant. Similarly, if we open up variant 2 and sort by reference designator, we can see that C5 is missing, as well as R3. as those were not populated for this variant. So each variant gets a separate part number in Teamcenter, as well as a bill of material reflecting what is populated for that variant. Now let's look at the library integration, beginning with a part search and initiating a part workflow. From Altium, if we go to add a new component, so we go to our Components panel and do a search. We're going to search for a database component that has a capacitance of 10 picofarads. We execute this search and see that we have 5 of these capacitors, but all of them have a tolerance of 20%, and we need a 10% tolerance. So we will initiate a part workflow as a new part request to request a new component to be created. We'll give this workflow a name and provide some information to the librarian on what we need. You can also attach related components as well as additional documentation, in this case a PDF of the data sheet of the component we want. We then submit the workflow. Again, we can check on its status by going to our inbox and seeing that it is at the librarian review stage. Let's review the Altium database library. This library is an Altium DB lib pointing to an access database for the component information. We can see our DB lib information here. If we open the access database, we can go to the capacitor table and see all the fields for this type of component. So the DB lib and the access database are the library for Altium. We need this information to reside within Teamcenter. So let's look at the EDA gateway for library setup and export the library to Teamcenter. The EDA gateway for library connects to the Altium database library and also connects to Teamcenter and acts as a middleman between the two systems. When we configured the gateway, we can see the database tables on the right-hand side with the various fields, and on the left-hand side, the Teamcenter properties. And we define the mapping between these. So part number from the database field goes to our item ID, part name goes to name, type goes to category, and so on. This way we map the Altium database library fields to Teamcenter properties. Once that mapping is complete, we can export this library to Teamcenter. This export will create the components within Teamcenter. We go into Teamcenter and search for components. We can search by classification. Here we can look at our capacitors and our disk capacitors and see the fields that we have for this class. If we select one of the components, we can see the classification parameters that were mapped from the Altium database library fields. So the export to Teamcenter from the EDA gateway for library created this information within Teamcenter. Now let's look at that new part creation workflow within Teamcenter. In Teamcenter, our librarian has a new workflow task. This task is our new part request, and this task is instructing the librarian to search to see if there is an existing component that will meet these requirements. We use a classification search, go to our disk capacitors, and look for 10 picofarad capacitors. We find 5 of those, so we go to the tolerance field and look for a 10%. All of them are 20%. Why would we have multiples? The librarian can look at the components and compare between them to see what differences. But this time we have no 10% tolerance capacitors available for this value. So the librarian will approve the creation of this new component. Since the librarian approved the creation of a new component, the librarian now has a new task to create the part. You need to create them, classify the part, and attach any associated data. So we use a quick link to create a new component, fill out the information needed, such as the name and description, add the component. Now that the component is created, we will classify it and enter the remaining information. So we select the correct class for this new component, which will be a capacitor and a ceramic disc capacitor. And then we'll enter all the necessary information and classify this component. Now that the component has been created and classified, we can attach required documentation, such as the datasheet and RoHS compliance forms. The component is then copied and attached to the workflow for further approvals. Now we can see the component is created in Teamcenter and has an approved status. In this section, we will synchronize the Altium database library with Teamcenter. Within the EDA Gateway for Library tool, you can select Teamcenter Synchronize from Teamcenter. Any component changes or new components in Teamcenter will now be synchronized out to the Altium database library. We can open the Altium component database and see the changes that were propagated to it from the synchronization. From Altium, we go to our component panel and refresh our search. We will now see the new 10 picofarad 10% tolerance capacitor, and it can be used in our design.